The Northern Lights are beautiful and odd, and they've understandably inspired tons of myths over the years. Like the Vikings thought they were a bridge to Asgard, where Thor and the other gods live. And another Norse legend says that they're the light reflected off the Valkyries' shields. And then people in Finland thought it was the Archangel Michael, John Travolta, fighting Beelzebub, the devil. The problem is, those are wrong. They're all wrong. It was actually Galileo Galilei, the famous early astronomer and recanter of science, who gave the Northern Lights their name, the Aurora Borealis, which in Latin means dawn of the north. But it wasn't until Norwegian scientist Christian Birkeland in 1896 figured it all out that we came to fully understand what causes the Northern Lights. See, in the center of the Earth, you will find hot, molten iron just roiling around under tremendous gravitational pressure. And this roiling effect of the molten iron creates magnetic fields that shoot out from the center of Earth through the crust and into the space around the planet. That forms what's called the magnetosphere, and it's a good thing we have it because we're constantly being bombarded by charged particles from the sun. The sun is so hot that it exists in a fourth state of matter. There's gas, liquid, solid, and then plasma. And in plasma, ions, which are positively charged atoms, and electrons just float freely around one another. And these particles have such a high energy charge that they can escape the massive gravitational field of the sun and barrel toward Earth at like something around 1,000,000 miles an hour, like a shotgun blast full of solar hate. That's called the solar wind. When these particles encounter our magnetosphere, most of them just kind of bounce harmlessly off. The Earth is saved. But some of them manage to get through at the places where the magnetosphere is weakest, at the North and South poles. You follow me? When the electrons that make it through our magnetosphere and into our atmosphere encounter oxygen and nitrogen, the electrons transfer energy to these atoms and excite them. And to calm back down, the oxygen and the nitrogen have to shoot off some of this energy, which they do in the form of tiny packets of light called photons. Beautiful, beautiful photons. Depending on where in the atmosphere the electrons interact with the oxygen or the nitrogen, different colors will be produced. Like for example, oxygen up to about 150 miles will produce a nice yellow-green color when electrons bombard it. Above that, it emits a nice red color. And then nitrogen, up to about 60 miles into the atmosphere, puts out a really beautiful blue. And all these colors can mix together, forming beautiful glowing pinks and purples and whites. It's like Miami Beach up there. So this interplay is most vibrant during solar storms, which depend somewhat on the solar cycle. And it's always going on. But the thing is, you can't see the Northern Lights during the day because they tend to be outshined by the sun. So tell us, have you ever seen the Northern Lights? Let us know in the comments section below. And while you're down there, don't forget to subscribe. And for even more awesomeness, visit our website at brainstuffshow.com.